Hello. Today we will start the review for the final exam. There are a total of 39 questions. Part 1 of the review covers the material from exam number 1 and exam number 3. We will use Proctorio through Blackboard for the final. Review for exam number 1. We start with some basic definitions. We have population versus sample, categorical versus quantitative. In particular, the measurement scale associated with the categorical data will be either nominal or ordinal, based on whether or not you have a ranking. Associated with quantitative data, the measurement scale will have either interval or ratio scale data based on whether or not you have a natural zero. Next on the list is discrete versus continuous. If it's countable and it's discrete. If the data can take on, the variable can take on any value, it will be continuous. And we have next on the list is parameter versus statistic. If the measure is associated with the population, it will be parameter. And if the measure is associated with the sample, it will be statistic. Next, we need to know how to read a histogram. So you have this histogram, you have two different types of operations. One, I'm giving you X, you need to find Y, or I'm giving you Y, you need to find X. The keywords are very important. So if the keywords is above, you count from the right. If it's the keywords it's below, you count from the left. And then there's one more case is in between. 3, you need to know how to read the stem and leaf display. You follow those 2 steps. Step number 1, you find the ordered array based on your stem and leaf display. And then step number 2, you need to find the percentage distribution. Topic number 4, giving a set of data with sample size n, you need to know how to find the mean, x bar, and you need to know how to find the standard deviation. And this is the equation. So you set up a table to find the numerator, xi minus x bar squared, divided by n minus 1, and you take the square root to get the standard deviation. And you also need to know how to find the fine number summary, giving an ordered array from R1, R2, all the way to Rn. Your minimum is R1, your maximum is Rn, and you also need to find Q1, Q2, and Q3. Now, to find Q1, Q2, Q3, you're going to have 2 concepts. One is the position, and the other one is the value. So you use P over 100 times n plus 1 to find the position, and this value we divide into the integer part and the decimal part. And the value is going to be Rk plus D times Rk plus 1 minus Rk. And for Q1, you set P equals to 25. For Q2, you set P equals to 50. And for Q3, you set P equals to 75. Number 5 on the list is some basic probabilities, and we use this addition law to compute the probability of A union B, which is equal to probability of A plus probability of B minus probability of A intercept B. And the key word will be OR. Now, for the conditional probability, the keyword will be given, and we will use this equation, probability of A given B equals to probability of A intercept B over probability of B to solve the problem. Now, if A, B are independent, then the probability of A intercept B is equal to probability of A times probability of B. Now, number 6, giving a discrete probability table, we need to do the following. 1, we need to find some probabilities. 2, we need to find the mean mu. 3, we need to find the standard deviation sigma. So to find some probability, we need to follow the keywords to write down the probability statement. At most, then the probability statement will be probability of x less than equals to A. For the keyword at least, the probability statement will be probability of x greater than or equals to A. Now, between with endpoints, then the probability statement will be probability of x greater than or equal to A, less than or equal to B. Now, to find the mean, we need to use this equation, mu equal to sum of xi times fxi. So we set up a table to find the mean mu. To find the standard deviation, we first find the variance. So we set up this table to find xi minus mu squared times f of x, and then we sum them up to get the variance, and then we take the square root to get the standard deviation. Number 7, binomial distribution. So we have this random variable x follows the binomial distribution with n and p. To find the probabilities, we need to use this equation. So f of x equal to this combination n object, you take x of them, and p to the x times 1 minus p to the n minus x. And this combination can be computed by n factorial over x factorial times n minus x factorial. So, and then you times p to the x times 1 minus p to the n minus x to get the probability, where x start with 0 and then 1, 2, all the way to n. Now, to find the mean, you just need to use n times p. Let's see this example. Giving this binomial distribution with n equals to 5, p equals to 0.27, I ask you to find the probabilities of x is at least 2, x is at most 2, x is between 1 and 3, with the endpoints are included. So let's look at the first one. X is at least 2. So the probability statement will be probability of x greater than or equals to 2. That means we need to do for x equals to 2, find the probability, x equals to 3, x equals to 4, and x equals to 5. So you have to do 4 calculations. And for this particular example, I'm going to use the complement or the shortcut to solve the problem. So this probability of x greater than or equal to 2 is equal to 1 minus the sum of probability x equals to 0 plus probability x equals to 1. So you can see it from this table. And for probability of x equals to 0, we use the equation. So you have n factorial, which is 5 factorial, over x factorial, which is 0 factorial, and then n minus x, which is 5 minus 0 factorial. And then 0.27 to the 0 power, and 1 minus 0.27 to the 5 minus 0 power. So that you have 5 factorial and 5 factorial cancel. 0 factorial is 1, and 0.27 to the 0 is also 1. So you have 0.73 to the 5th. Now, for x equals to 1, you have 5 factorial over 1 factorial times 5 minus 1 factorial. So this is 4 factorial, and you have a 5 factorial, and this will give you 5. And then you have 0.27, and then you have times 0.73 to the 5 minus 1, which is 4. And using your calculator, you'll be able to get the value 0.4093. Now, for s is at most 2, we also write down the probability statement. That's probability of x less than or equals to 2. So to find the value, you have probability start with x equals to 0, and then probability of x equals to 1, and then the probability of x equals to 2. So from the previous example, you get 0.73 to the 5th, and then plus 5 times 0.27 times 0.73 to the 4th, and then for x equals to 2, you have 5 factorial over 2 factorial times 3 factorial times 0.27 to the 2 plus times 0.73 to the 3rd, and use your calculator, you'll be able to get 0.8743. Now, for the probability of x between 1 and 3, the endpoints are included, will give you the statement of probability of x greater than or equal to 1, less than or equal to 3, which is equal to the probability of x equals to 1, plus probability of x equals to 2, plus the probability of x equals to 3. So for the probability of x equal to 3, you have 5 factorial over 3 factorial times 2 factorial times 0.27 to the 3rd times 0.73 square, which will give you 0.7717. Now, review for exam 3, we start with this chapter 12, the chi-square test. And step number 1, state H0 versus H1 is given. And then for step number 2, we set up a table to find the test statistic chi-square equals to the double sum of Fij minus Eij square over Eij, where this expected frequency EIJ can be computed by row I total times column J total over the total sample size. And we will find Fij from the given table, and then we will find this expected frequency EIJ from this equation, and then we will compute Fij minus Eij squared over Eij for each cell, and then we sum them up to get the test statistic chi-square. And then step number 3, we need to find the critical value chi-square alpha from the chi-square table with degrees of freedom equals to k minus 1. And after we find the critical value, we reject F0 if this chi-square, the test statistic, is greater than or equal to the critical value. And this is a right-tail test. So you can see from this plot, and you have this chi-square alpha as your critical value, and this is your rejection region. If your test statistic is greater than your critical value, you reject as 0. If your test statistic is less than your critical value, you fail to reject as 0. For this chapter 14 simple linear regression model, we have this regression equation y hat equal to b0 plus b1 x is given. We also have SST, SSR, n, and the sum of square with respect to x value. So the sum I equal to 1 to n of xi minus x bar square. And we need to answer some questions. And to find the test statistic tcal, we need to follow those 3 steps. Step number 1, you need to find the standard error of estimate S. S is equal to the square root of SSE over n minus 2. And we do not have SSE, but we have SST and SSR. So this is equal to the square root of SST minus SSR over n minus 2. And step number 2, we need to find the standard deviation of the slope B1, which is SB1. This is equal to S over the square root of the sum of the square with respect to x value. Make sure you take the square root. And then step number 3, we find the test statistic. So this tcal is equal to B1 over SB1, where B1 is your slope. So for the confidence interval, this 101 minus alpha % confidence interval for the true slope beta 1 can be computed by this equation. So it's B1 plus or minus t's of alpha over 2, that's your critical value, times SB1. Now for the 101 minus alpha % confidence interval, for the mean value of y is given by this equation. So for y hat star plus minus t's of alpha over 2 times s times square root of 1 over n plus s star minus s bar square over the sum of si minus s bar square. Now, to find the coefficient of determination, we use this equation r squared equals to SSR over SST. For chapter 15, the multiple regression model, we need to know the following. When we predict the value of y for a given value of the independent variables, the unit is very important. B. This 101 minus alpha % confidence interval for the slope beta I is given by this equation bi plus or minus t's of alpha over 2 times SBI. And you can find bi, SBI from the Excel output. And to find the critical value, the degrees of freedom will be n minus p minus 1, where p is the number of independent variables or number of x's. N is the sample size. C. If the p-value is less than or equal to alpha, we reject H0 for the hypothesis testing, then the corresponding independent variable is significant in explaining why and should be included in the model. Otherwise, it should not be included in the model. For chapter 19, the control chart, I would like to mention the following. A. How to determine if a process is in control will based on the following two conditions. Condition number 1, all points are within the control limits. Condition number 2, no patterns over time. B. To find the upper control limit, lower control limit for the X-bar chart or R chart, we need to use this equation. UCL is equal to X bar bar plus A2 times R bar. LCL is equal to X bar bar minus A2 times R bar. And for the R chart, UCL is X bar times D4. LCL equals to R bar times D3. Note A2, D3, D4, the control factors obtained from the table will be based on the sample size n. This is extremely important. C. For the P chart, the proportion P or the center line can be computed by this equation. P equals to the total number of defects over total number of samples, which is x1 plus x2 all the way to xk for the numerator, and the denominator is n times k. So let's look at this example for the chi-square test. And we wanted to test not all population proportions are equal. And that's step 1. And step number 2, we need to set up the table to find the test statistic chi-square. And from the sample result table, we'll be able to find the given frequency. So you have 48, 19, 23, etc. And for each of the cells, we need to compute the expected frequency. So for this 48, you have 90 times 100 over 240 to give us the expected frequency, which is 37.5. And then we compute Fij minus Eij squared over Eij, which is 48 minus 37.5 squared over 37.5, which will give us 2.9400. Let's see one more. So you have this observed frequency 19, and your expected frequency will be 90 times 70 over the grand total 240. and that will give us 26.25, and to compute Fij minus Eij squared over Eij will be 19 minus 26.25 squared over 26.25, which will give us 2.0024. So we do all of them for each cell and sum them up, we will get this test statistic 8.552. Now, step number 3, we need to make a decision. And we have 3 proportions, or say 3 populations. And the degrees of freedom will be 3 minus 1, which is 2. And from your chi-square table, with alpha equal to 0.05, this chi-square 0.05 is 5.991. And we draw this number line, and you have your critical value to be 5.991, and the test statistic 8.552 is more than your critical value. On the right, we reject as 0. And this is the end of part 1 of the review.